So today we're going to look at how we can simplify some expressions that contain our factorials. And I'm going to show you two different ways that you can expand them out and simplify, and you can pretty much choose whichever way you like better. So obviously one way that we can simplify these factorials out is to just expand them by using the definition of the factorial. So if I were to use the definition of for 8 factorial, I would start with the number 1 and multiply all of my integers until I got to that number of 8. And then in my denominator, I can do the same thing. I can use the definition and expand out 6 factorial. And then using our simplification techniques for fractions, we can then just reduce any common factors in the numerator and the denominator. And then whatever's left behind would be our answer. So for this problem, we would get 7 times 8, or 56. Now, obviously, as these numbers get bigger, I'm not going to want to have to expand these out forever. So what I'm going to show you is a different way for expanding these factorials out. So instead of starting with 1 and then counting up until we get to our value, I'm going to actually start with the value and count backwards, working my way down towards 1. And as I'm expanding out, what I want to do is look for whichever factor is larger. So in this case, 8 would be my bigger value. And I'm going to expand that out, but then stop once I get to that value that matches my denominator there. So instead of saying 8 times 7 and then doing 6, 5, 4, 3, 2, 1, and then in the denominator doing 6, 5, 4, 3, 2, 1, I'm just going to say, well, the rest of it is 6 factorial. And then in my denominator, I'm not even going to bother expanding. I'm going to keep that 6 factorial. And then I can just simplify those. And now I know 8 times 7 is 56. All right. Notice I received the same answer. I just had to do a lot less work in this problem because I didn't have to keep on expanding out all of those numbers. Okay. So let's look at a couple other examples. Sometimes when you're looking at these, you might see that there are 2 different factorials in either your numerator or your denominator, and you're going to want to simplify those out. So again, I'm going to use that same trick. So I look for my larger number, which would be 9, and I'm going to start expanding that out. And then I'm going to stop once I get to that common factor in my denominator, and I'm going to choose the larger of my 2 factorials down there. So I'm going to expand this out as 9 times 8 times 7 factorial. So that down here, I'll be left with 3 factorial times 7 factorial. And that'll allow me to cancel that out. And I still want to simplify this fraction out a little bit more. So I'm going to keep this as 9 times 8 in my numerator, but now I'm going to actually take the time to expand 3 factorial out. 3 factorial, you can either do 1 times 2 times 3 or 3 times 2 times 1. It doesn't really matter. And then you can go ahead and simplify your fraction however you want. So I'm just going to do a little bit of simplifying this way. 3 goes into 9 3 times. 2 goes into 8, 4 times. So then 3 times 4 would give me my final answer of 12. I could have also multiplied and done 72 divided by 6 and received an answer of 12 that way as well. All right. Now, sometimes as you're working through these, you might encounter some factorials that have variables instead of numbers. And we simplify them the same exact way. And again, I'm going to use the counting down technique. So if I'm thinking through numbers, obviously n factorial is bigger than n minus 1, right? Because 5 would be bigger than 4, because that's what 5 minus 1 would be. So when I'm working through these, I'm going to start with that number n, and I'm going to keep multiplying by the decreasing integers. So to find the next value down, I would subtract 1. So, you know, when I went here, I did 9, then I subtracted 1 to get 8, and I subtracted 1 to get 7. So if I'm starting with n factorial, I'm going to do n, and then n minus 1, my next one would be n minus 2, my next one would be n minus 3, and so forth. But since in my denominator, I had n minus 1 factorial, I'm going to stop there. So my numerator would be n times n minus 1 factorial divided by that denominator of that n minus 1 factorial. Those would cancel out, and my answer would just be n. All right. So again, as I'm simplifying these out, I'm just going to keep expanding them until I get a matching term in my numerator and denominator, a matching factorial term that I can cancel out. All right, so same thing in my next example. If I'm thinking about which one of these is the bigger expression, obviously if this a number, if you add 1 to it, that's higher than the other number. So my numerator is my bigger value. So I'm going to start with that n plus 1. And then I'm going to multiply by the decreasing values. So to get to my next lowest number, I would subtract 1. So that would just be n factorial. And since that's what's in my denominator, I'm going to go ahead and just stop right there. And so my answer to this one would just be n plus 1. All right. So let's look at one more example where we kind of have a couple factorials combined. Notice in example 5, I'm mixing numbers and letters. So again, because this is a fraction and these are being multiplied together, I can treat the numerator's product as 2 different pieces and then this denominator as 2 different pieces. So looking at just the number components, 4 is my bigger number. So I'm going to start breaking that down. So that'd be 4 times 3. And since my denominator had that 3 factorial, I'm going to separate 4 factorial as 4 times 3 factorial. And then for my n's, the n plus 1 would be my bigger number. So I'm going to take n plus 1, multiply by n, my next decreasing value, by subtracting 1. And again, that's going to match with that n factorial that was in my denominator. So now I can cancel the 3 factorials, and I can cancel those n factorials. So my answer would be 4 times the quantity of n plus 1, or if you wanted to distribute that, 4n plus 4. All right. So hopefully that helps you work with our simplifying for today. If you have any questions, feel free to reach out.